All right, we are going to further practice prime factorization. I'd like you to follow along with me in your notebook. As we practice this prime factorization, our goal is to get prime numbers. So let's just quickly make a list of prime numbers. Now we know 1 is kind of a goofy number. It's not prime and it's not composite, so we're going to skip that for now. 2 is prime. The only factors are 1 and 2. 3 is also prime. The only factors of 3 are 1 and 3. 4 is not prime. 4's factors are 1 in itself, 4, but also 2. 5 is prime. 6 is not prime. It also has the factors 2 and 3. 7 is prime. 8 is not prime. 9 we often think is prime, but we have to remember that 9 also has factors 3 and 3, or just 3. 10 is also not prime. 11 is prime. Now we could keep going, but those are the numbers that we will use the most often. So we want to keep those in the back of our mind because those are the numbers we want to use in our prime factorization. So let's go ahead and get started. We'll start with a smaller number, 36. Our first step here is going to be thinking of factors of 36. Now we know 1 and 36 are factor pairs of 36, but as our rule was yesterday, we can't use 1. 2 goes into 36 because it's an even number. 2 times 18 gives us 36. So let's go ahead and use those two numbers in our first branch of our factor tree. Now we're thinking, did we get any prime numbers? Well, we see there's 2, and here's our 2, so we go ahead and circle that. Next we look at that 18. Is that prime? No, so we have to keep going. So now we have to think, what are the factors of 18? Well, again, we know 1 and 18 will not work because we cannot use 1. 2 will work because 18 is even. 2 times 9. So let's use that factor pair here because, again, then we get a prime number that we can circle. So 2 is prime, we circle it. 9, we remember is not prime, so we need to further branch that down. Again, we cannot use 1 and 9. We can use 3 and 3. Let's go ahead and write those in. Now 3 is prime, so we circle both of these 3's. Now we have to write our prime factorization. So we are going to remember to bring down each of these circled prime numbers and write them as the prime factorization. Now we want to write the numbers least to greatest, so we'll start with 2. So we have 2 times 2 times 3 times 3. And this whole prime factorization is equal to 36. All right, so let's practice further with our prime factorization. Now I want to remember those prime numbers again. So I am going to rewrite them over here. 2, 3, 5, 7, 11. But let's now use a little bit of a bigger number than 36. Let's go with 180. So I know my first step is going to be to branch this out into a factor tree. Again, I can't use 1 and 180, but I can use 2 because 180 is even. I know that 2 times 90 will give me 180, so I'm going to go ahead and use 2 and 90. I personally like to use 2 as much as possible because I know then I'll be able to circle it. So now we have to look to 90. That is not a prime number. And so we have to figure out what factors it has. 1 and 90 will not work. 2 does work because it's an even number. 2 times 45. So we're going to go ahead and write those two factors here. I love 2 because I can circle it. So we're going to circle that prime number there. 45 is not prime, so we are going to branch that one. Now I've run into an issue I know I can't use 1 and 45, but now 2 does not go into 45. So I'm going to go look back up here at my prime numbers and see which prime numbers can I get out of 45. Well, I know 45 is an easy one. So 45 divided by 5 is 9. So I'll go ahead and write 5 and 9. 5 is prime, so I'll circle it. Remember, 9 is not prime, so we have to further branch 9 off. 1 and 9 can't use. I can use 3 and 3. So I'm going to finish this off by circling my prime numbers at the end. And now I have to write my prime factorization. Like I said before, I want to use, or I want to order my numbers least to greatest. So I'll bring my 2's down first, then my 3's, and lastly, my 5. So that'll look like this. 2 times 2 times 3 times 3 times 5 is all equal to our original number, 180. All right, we're going to do one more. Again, I want my prime numbers up here for me to remember. 2, 3, 5, 7, 11. We are going to go an even larger number than 180. We are going to start with 525. So right away, I know, again, I can't use 1. That one's out. But I don't have that nifty 2 that I can use. I do know, since 525 ends in 5, that 5 is going to go into it. Now, it's really important that we make sure we're getting our factor pairs correct. So if you're not sure what 525 divided by 5 is, you need to take the time to go do that work off to the side. Now, I already know that 5 and times 105 gets me to 525 because I did the math off to the side. So I see 5 prime, so I'm going to circle it. 105 though, not prime. So I need to further factor that down. Cannot use 1 in 105. But I know that this ends in 5, so again, 5 is going to go into it. Since I don't know what 105 divided by 5 is off the top of my head, I need to go off to the side and do the math. If you also don't, you need to do that as well. Since I've already done the math to make this video a little speedier, I know 5 times 21 gets me to 105. Again, I see I got my 5, so it's prime, and I'll circle that. 21 is not prime, so I need to further branch that down. 1 and 21 will not work. So now I'm looking back up to my prime numbers. What prime numbers go into 21? Well, I know 3 times 7 gets me to 21. So I'm going to use that factor pair in my branch. That gets me 2 prime numbers. I'm going to go ahead and circle those. Now again, I need to bring down my numbers, my prime numbers, to write the prime factorization. And we're going least to greatest. So 3 will be first, then my 5's, and finally my 7. That'll look like this. 3 times 5 times 5 times 7. That gets me 525.